Hey guys, Mr. Gibson here. So I just wanted to go ahead and record a video about your interactive notes for 4.1. So what I've gone and done is I have filled in all of the blanks, and your all's responsibility is to go through and answer the questions in those margins. So like right here. Now on yours, this will be filled in. Now, there are some places where you will need to do the practice problems throughout, and it will tell you practice, and I believe I've actually highlighted those so they stand out a little bit to you. So you'll see parts where there's like an example, and I have that done, and then there's parts where it's practice that you will do, okay? And then at the very end, you're going to want to do the summary page. Now, I want to make sure that you guys know what you're doing and you're not confused after this assignment so that you don't miss any questions on a quiz or anything. So I'm going to go ahead and go over the summary page. I highly recommend you wait to listen to this next part of the video until after you've completed it. It's always better to have tried it first and then watch the video of me going over it just to make sure that you get the right answers, okay? So hopefully, if you're watching this part of the video, you've gone through and you've completed the summary page and you are just checking to see if you got these right. So let's see how we did. Number one, what are atoms looking for when they react to form compounds? The atoms are looking to become stable. They're looking for stability, okay? Atoms are only stable if their valence electron shell is full, okay? So the noble gases, that far right column, group 8A on the periodic table, all of those elements have full shells, full outer shells of valence electrons. So they are stable. That's why they don't react with anything. Everything else on the periodic table is technically unstable because they want to have those same electrons as the noble gases. Okay, so when they are reacting with each other, they're trying to gain, lose, or share electrons in order to have a full outer shell, just like the noble gases. All right, what are 3 ways atoms will gain stability? I just kind of gave that away. They will either gain electrons, which is what nonmetals do. They will lose electrons, which is what all the metals do, or sometimes they will share electrons. When they share electrons, it forms what's called a covalent compound. We're not talking about that just yet. We're only talking about ions and ionic compounds, which is where atoms are gaining electrons or losing electrons. Okay? When an atom reacts to form compounds, what are they trying to look like? Like I said, they're trying to look like the noble gases because the noble gases are stable. They don't need to gain or lose electrons. Okay? Why? Because noble gases have full valence shells, okay? Their outer shell of electrons is full. Just think of like after, Thanksgiving dinner or something like that, or after you have like a big lunch or a big meal, you're full, you're happy, you just want to go take a nap. That's how the noble gases are. Their valence electrons are full. They are harmonious. So they don't need to gain or lose electrons, and all the other atoms therefore want to be like them. Okay, so for the following representative elements, determine the number of valence electrons. Remember, the number of valence electrons for a representative element, meaning it's group A, is just the number of the group that they're in. So sodium is in group 1A, so it has 1 valence electron. Francium, also in group 1A, so it has 1 valence electron. Carbon is in group 4A, so it has 4 valence electrons. Neon is in group 8A with the noble gases, so it has 8 valence electrons, so it's stable. Bromine's in group 7A, those halogens, so it has 7 electrons. Helium's in group 8A, but this is a tricky one. Helium only has 2 electrons. If you look at its atomic number, it's only 2. So its number of valence electrons is actually 2. It's the only exception to the rule. Okay. Lithium is in group 1, so it's got 1 valence electron. Boron is in group 3A, so it's got 3 valence electrons. Germanium is in group 4A, so it's got 4 valence electrons. I had to look up for that one. All right, so now it says write the electron dot structure for the element. So the electron dot structure is simply where you type or you write the chemical symbol off the periodic table, and then you draw a dot for however many valence electrons that element has. So if it has 4 valence electrons, you're going to draw 4 dots. Now, there is a certain way you have to draw the dots. Pretend that each chemical symbol has 4 sides. Okay, so you can put an electron on one of any of the 4 sides, and you also cannot double up the electrons until you can't put 2 right next to each other until you have 1 on all 4 sides. Remember, electrons don't like to be around each other because they're all negative. So let's go ahead and type. I'll make my font size a little big here. So germanium here, Ge, remember, has 4 valence electrons. So I'm going to go through and I'm going to draw 4 dots. 1, 2, 3, 4. Notice I didn't do 1, 2, 3, 4. I have to have 1 on each side first. Okay, so there's germanium. Lithium is Li, and it has 1 valence electron. So I'm just going to draw. I'm just going to draw 1 dot, and it doesn't matter what side you put the 1 dot on. Okay. Arsenic, that is in group 5A. Its symbol is As, and because it's in group 5A, it has 5 valence electrons. So I'm going to go through and draw 5 dots. 1, 2, 3, 4, and the 5th one just gets doubled up now. 5. Boom, there you go. Tellurium, Te, is in group 6A. So I'm going to type Te. Because it's in group 6A, it has 6 valence electrons. 1, 2, 3, 4, 5, and 6. Boom, there we go. And xenon is a noble gas. It's got, well, its symbol is Xe, and because it's a noble gas, it's in group 8A. It has 8 valence electrons. And I want you to notice something here when I draw this, if I can draw it well. 1, 2, 3. Okay, I didn't do a great job at drawing that, but it looks full when I draw it well. Hopefully on yours it looks better than that. It looks full. It looks, oh, that's complete. Its electrons are full. You can almost tell by looking at its electron dot structure that it's stable. Over here, like arsenic and tellurium, it looks like stuff's missing. It's because it is. They want to gain electrons so they can look like those noble gases. Okay, I hope that makes sense. Number 6, what is the chemical formula for the ions that form from the following elements? Remember, you got to write the symbol and then the charge. Calcium is in group 2A. So it's a metal, so it's going to lose its electrons. Okay. It's going to lose its 2 valence electrons. So first you write the symbol Ca. And then you're going to write its charge. Well, if it loses 2 electrons, okay, then it's going to have 2 more protons than it does electrons, meaning it's going to have a positive 2 charge. Okay. You can also memorize the charge based on where it is on the periodic table. So all the elements in group 1 have a +1 charge. Group 2 has a +2 charge. Group 3A has a +3. Group 4A could have a plus or -4. Those are a little tricky. Group 5A is where we start going down. That's where we start gaining electrons. So group 5A, those nonmetals would have a -3 charge. Group 6A would have a -2, 7A a -1, and then group 8A is the noble gases. They're never going to have a charge, okay, because they don't gain or lose electrons. Phosphorus, so letter P, it's in group 5A. It's only 3 spaces from the next noble gas, so it needs to gain 3 electrons. So because it's gaining electrons, it's going to make it more negative. So we know it's going to be negative, and it's going to gain 3, so we know it's going to be a -3. Oxygen is in group 6A. Almost type 6A. So its symbol is O, and because it's in group 6A, it's going to have a -2 charge because it's going to gain 2 electrons to get to that nearest noble gas. Arsenic is in group 5A. So it's going to have a -3 charge. Aluminum is in group 3A. So it's going to have a +3 charge. And francium is in group 1A, meaning it's going to lose 1 electron and have a positive. Well, you can do this 1 or 2 ways. If it has a 1 as its charge, whether it's positive or negative, so like this one is +1, I wouldn't count it incorrect if you left it as positive 1, but it's kind of like in algebra where you have like 1x. You don't need that 1 there. So you could just leave it as plus. And most of the time, that's how you'll see it. Okay, it's just a plus sign. We know that there's like an invisible 1 there. Okay, so number 7, write the full electron configuration for the element and the ion of bromine. Okay, what noble gas is bromine trying to be like? So the noble gas bromine is trying to be like is the next nearest one. So that's going to be krypton. Okay. And for the sake of time, I'm not going to write out its whole electron configuration, but I am going to do just that last little bit there in the p block. So it's group 4, so it would end in 4p. Now bromine ends in 4p5. Okay. It can, remember, p can hold all the way up to 6 before it's full. So when it gains that 1 electron, it becomes 4p6. And now it is stable. And now it has the electron configuration as the same one as krypton. Okay, and that's why it would gain that 1 electron. All right, I hope all this makes sense. If you guys are confused about anything, please email me and ask me so that I can clarify it. And if you guys need help, anything as far as the assignment goes, just let me know. All right, guys, thanks and good luck.